And we're rolling.
Hi guys. Okay, so first of all, everyone say hi to the camera. We are being recorded again.
Hi.
Or I'm being recorded again. You guys are a bonus. So. Hello, camera. Okay, so someone had a question for me?
Yeah, I had 2 questions on 2 problems.
On 2 problems on the board?
Yeah.
Okay, so let's put that. Recheck. Okay, you go ahead and hold that for a moment. Hold on to those for a moment. I'll need to get the well work up on the board.
How often?
We've done lots of bell work before.
Is it code for like opening exercise?
Yeah, opening exercise, bell work, they'll both mean the same thing. What's that? You left your book in your locker, go. You can pass. Okay. Okay, so opening exercise. Okay, so up to this point, we've been working on the basics of integration. Today we're going to start moving beyond the basics, and we're going to be working on some more complicated integration concepts. So for opening exercise, I'm going to put up just a couple of the basic problems, just to get us in the right frame of mind. I want you to compute the integrals for me. Let's say the integral of e to the x plus x dx. The integral of sine of x plus the square root of x dx. And for the last one, let's say the integral of x plus 2 squared dx. Okay, should be able to finish these problems in 4 minutes, probably a little less, but you're computing those integrals. Okay. So what I would do is this. Now, let me. So we have here. We have there the square root of 5x to the 3rd power over 5x to the 3rd power. Yeah. Well, one of the rules of square roots is that you can split it up into product. Which means that I can split this up, this whole thing up, into 2 fractions. Okay, the square root, this is the square root of x to the 3rd power, which means this is really to the 3/2 power. I can divide these powers easily enough, and then I'm just left with a constant times the power. What's up? You know what's doing the problem, not me. You could do the chain rule backwards, that's what we're going to learn today, but you don't have to do the chain rule on this one. That's x plus 2 times itself, right? You could form it. those problems, John?
Alright, hold on, I got stuck somewhere.
Okay, I'll be looking in just a moment. Keep it. Take this. Okay, attendance. Diana. Tierra.
Here.
Gamble. John.
Here.
Kelsey. No Kelsey? Tamara.
Here.
Jonah. B.
Yes.
Chantel.
Here.
Anaya.
Here.
Kamala.
Here.
Travar.
Here.
Urbina.
Here.
Michael. Solander. What's up? We can just leave this at. That's just a constant. Okay. Now, so we have x to the 3 halves over x. So what do we do when we divide factors? Subtract. So 3 halves minus 3. So that's 3 halves minus 3, that would be 3 halves minus 6 halves. 6 halves minus, or 3 halves minus 6 halves is negative 3 halves. So now we just take the derivative like normal, like we're doing it, right? We just take the derivative like normal, bring it down, subtract that by 1. Which one? I don't have an answer. Yeah, okay. Okay, I'll check on my words. Okay, then you should turn that over. That's fine, that's fine. Just as long as I see, I'll figure it out. I'll manage.
I'll think it leads you.
Okay, so what's the antiderivative? So we do the cosine, right? So what's the antiderivative of sine? What do you take the derivative of the sine? Sine, cosine? Thank you. Yeah, well, the derivative of negative cosine is sine, right? So the antiderivative of sine is cosine. Okay. And then you already converted that to a power, right? So what do we do? What's 1 half plus 1? Okay, so it would be x to the 3 halves. Then it would be. You got it? And at that point, it's just simplification. Okay, time's up. So, let's go ahead and take these integrals. So, we have here the integral of e to the x plus x. Everybody, what's the antiderivative of e to the x? I love e to the x. It's our best friend in the entire calculus world. And what is the antiderivative of x? X squared over 2.
Plus C.
Plus c. Always add a c when you're done. Okay, good so far? Raise your hands if you got the first one right. Okay. Pretty good. Okay, next one. What's the antiderivative of negative? What's the antiderivative of sine?
Cosine.
Negative cosine. Awesome. And how are we going to handle the square root? Yeah, this is really x to the half. Okay, what do? We add 1. What's 1/2 plus 1?
Yeah.
So we get x to the 3/2 power. And then what do?
2.
We multiply by 2/3. We're dividing by 3/2, but that's the same thing as multiplying by 2/3. So we have 2/3 x to the 3/2. Okay, is that it? Plus c. I love the way you guys remember the c. Class after my own heart. Okay. And what are we going to do here?
Foil it.
We can expand it out and FOIL. This is really the integral of x plus 2 times x plus 2 dx. Okay, what does this give us?
Foil.
Or how,
Squared plus 4x plus 4.
x times, so that would give us x squared plus 4x plus 4. Okay, now we just take the integral of each term, or antiderivative of each term more properly. Antiderivative of x squared,
X cubed over 3 plus 2x squared.
yeah, because you're adding 1, so it'll be 1/2 x squared, and 4 over 2 is 2, so you have 2x squared. Plus 4x
Plus c.
plus c. Always the c. Okay, raise your hands if you got this last one all right. Okay. I'm seeing a little more than half of us. If you okay, great. So, okay, so we have this problem here. It's not too bad. We have to expand it out a little bit, yeah? What if, let's take a moment and ask ourselves, what if this was x plus 2 to the 10th power?
We're still going to expand it.
We could still expand this, right? X plus 2 times x plus 2 plus 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 x times x plus 2 times x plus 2. Bleh. Is that a practical way to solve this problem?
No.
No. Today we're going to learn a better way. So, I'm going to go ahead and put up the title and objective of today's lesson. Get out your notes and copy down the title and objective. Today, we are moving beyond the basics.
It's Wednesday, man. Come on.
It's Wednesday, my dudes.
Sanitizer.
It's over here.
Here, I'll give it a try.
But I'm not throwing.
And
You can see, John. Our objective today is to compute. Our objective today is to compute the integrals of certain composite functions. up here. So, today we're going to be taking the integrals of certain composite functions. We will not be looking, there's no one formula that lets us take the integral of any composite function.
Oh, excuse me.
But there are a couple of powerful techniques that can let us take the integrals of certain functions. So first of all, what is a composite function? Anyone want to stick their necks out and field this question? What is a composite function?
What I'm so confused about.
Well, that's composite would certainly imply that. What does composite mean?
It's just F of it, F parentheses G parentheses X parentheses parentheses.
That's the one. A composite function. Composite functions mean, in simpler terms, it's a function within a function. So, for example, composite functions have the form f of g of x. So you have a function hanging out inside of another function. Now I want us to take a moment and just remember how to identify a composite function. Let's say I have f of x equals x squared times 2x. Is this a composite function?
No, it's a product rule.
Well, it's not really a product rule, it's just a function. We're not doing any derivatives or integrals on this. So. It's two derivatives and calculus. So is this a composite function? No, there's no functions hanging out inside of another function. How about, let's say, how about this one? Is this a composite function?
Yes.
No.
Yes, it is.
It is. We have x plus 2 hanging out inside of another function. So for this one, what is the outside function?
2, the square.
The outside function is x squared, and what's the inside? X plus 2. Yeah. Fair enough? Okay, let's try another one. Let's see, I'm going to call on someone to tell me what the outside and inside functions are. Let's see. Let's say I have h of x equals e to the sine of x. Jonah, what's the inside function for this one?
Or sine of it.
Okay, and what's the outside? You got it. Ravina, could you close that door?
Error.
So fairly straightforward. Okay, now let's try one that's a little bit uglier. What if I have what's the outside function for this one?
We got policy.
So our outside function. Our outside function is precisely that. Our outside function is sine of x times cosine of x. We can have the inside be in more than one spot. So what is our inside function? Okay, so here's our outside, and here's our inside. Okay, fair enough? Okay. Or let's try one last one. What if I have so we have e to the x on the outside, and what's inside? Our inside, well, we can think of it as two ways. Our inside is x squared, but then what happens? We have another inside. This one is a composite of a composite. So it goes x squared and then x plus 2. So the insidiest inside is x plus 2, then x squared, then e to the x. So this would be a function inside a function inside a function. Fair enough? Like a matryoshka. That's how you pronounce it? Oh no, I'm not Russian. Okay. So, how can we take derivatives of things like this? Or not derivatives, integrals. Okay.
Rick could let her do it, that's how you do it.
You make me do it, and then you watch?
Nah, you just make it. You smuggle him into the AP exam room and he does problems for you.
Oh, yeah.
Do you think we could get caught?
I don't think you would get caught, because I wouldn't do it. Okay. Okay, so let's go ahead.
How about if we got
Josh.
an evil twin?
Barles LaRue, you mean? Okay. So, okay, let's go ahead and take a look at the integral that we had with our opening exercise. X plus 2 squared dx. So what is the inside function here? Our inside function is x plus 2. Now we're going to, okay, trying to think of the best way to describe this. Okay, our inside is x plus 2. And our outside, what's our outside? Uh-oh. You know what, I gotta adjust the thermostat because it is very warm here. God, somebody set the temperature to 80. What's on here? Really?
Dang it.
Forgot about him.
Okay.
Checked out on
So let's think about, so looking at this, I'm not quite sure how to handle this integral right now without having to expand it.
Yeah.
But let's just take a moment and think about this. So this is a composite function, right? Now what's the rule that we use? So to find the integral, we need to find the antiderivative, right? So let's start from thinking about a derivative. If I have a composite function, f of u, where u is a function, what is the formula to find f prime? What's the formula for when I have a function inside another function? Well, what's it called, first of all? What was it called? Starts with ch. The chain rule.
I said that?
You did say it. You did. That's correct.
Why is it so
So how do we take the derivative of? Oh, let's write this a little differently. Let's say f prime of g. So what is f prime of x? 4. So what is f prime? There we go. That's the my notation was a little all over the place there. I'm a great believer in notation. So how do we put? What is the chain rule? How do we take the chain rule? How does the chain rule go?
Take the derivative of the outside function.
Mhm.
Take the derivative of the inside.
Okay, what do you do with the derivative of the inside? You just say the derivative of the outside and then the derivative of the inside? Okay. So, if I'm how does it work? Looks like we haven't done this in a little while, which is a problem because it was in the homework I assigned the other night.
So to take the derivative of that, you move the 2 down, do the inside.
We're not talking about a specific problem, we're talking about in general. Let's look at the formula.
Okay, so it's like, I don't know how to write down the rule.
Well,
It's like,
so we have an outside function, or f of x, and an inside function, or g of x. What do we do with the outside?
You just multiply it, or take the derivative of it.
We take the derivative of it, so we have f prime, and what do we do with the inside?
You leave it the same,
We
and then
leave
you
that
take the derivative.
alone, and then what do we do?
Take the derivative of g of x.
And then what do we do with it? We
Take the
multiply.
derivative, multiply.
Okay, so f of g of x prime is f prime of g of x times g prime of x. Yeah? So we're taking the derivative of the outside function here, and then we are multiplying by the derivative of the inside. So this is, written in kind of I think it's a Newtonian notation. Let's go ahead and write this using okay. So let's go ahead and rewrite this, or okay, better way. So if we have something that already looks like this, if we are taking the integral of f prime of g of x times g prime of x, if we are taking the integral of something that already looks like this, what is our answer going to be? So if I take the derivative of f of g of x, I get this. So if I'm taking the integral of this, where will I end up? F of g of x, we're going backwards. Does that make sense? So, now this whole system here of using f's and g's, it's a bit of a pain in the butt. So what we're going to do is we're going to make it look nicer. By saying that g of x equals u. So just u representing a function, so we're left with this formula here. And you move from there. So the integral of f prime of u times u prime dx is equal to f of u. Fair enough? Now, but suddenly we're not really working with x's anymore. Or rather, u prime. What is u prime? That's the derivative of u, right? Can I rewrite that using different notation? It's du dx, right? So I can replace this u prime with du dx. dx equals, that's just going to spit us out f of u. Oh. So technically, if I was just adding a constant to this, it would still work. So we'll go ahead and add a c there. Now, does anything simplify here? The dx's simplify, and in an action that would give reasonable mathematicians an aneurysm, but we do it anyway, we cancel out the dx's. And we are left with the integral of f prime of u du equals f of u plus c. So we're almost done. So, well, this is saying f prime of u, f of u out here. We're not really, well, sure. Uh-oh.
We're just doing walkthroughs.
Oh, hello. Say hi to Pima Community College.
Oh,
Yes,
I
I'm recording.
apologize, Mr. LaRue.
Don't worry about it.
Okay.
Okay,
It's just in the back.
so, okay, we'll leave it here. So this formula is, this formula we can call the u substitution formula.
Right.
Substitution formula. We probably shouldn't really think of it as a formula. We should think of it more as a method that can let us take the derivative of composite functions. Because here we have a composite function here. So here's the way that we actually use this formula. Okay, so here we have an inside and an outside, right? So our inside, what letter did we give the inside? Or are we calling that?
U.
Calling that u. So, u equals what? What is it though? In this particular problem, what is it? X plus 2. Now, on the outside, we have our outside function, which according to our formula, we call f prime of u. But we're here, let's just put it in terms of x. So what is our outside formula? Well, actually, let's keep it as u. So what is our outside formula? It's x squared, but what's the inside? But we gave it a new name, gave it a new name. We're calling it u. So we can replace that we can replace our outside here, or think of our outside in terms of u. So we'll call our outside u squared. So we're saying that u is x plus 2, and our inside is u squared, okay? We good? So, now that formula, however, does not work in terms of x, which is what we have over here. It works in terms of u. Make sense? So, if we could rewrite this as the integral of u squared dx, but can I take an integral with, except that it still is a dx. We didn't do anything to that. We didn't do anything to that u, right, to this dx, so it's still dx. But can we take an integral when these variables don't match like this? It doesn't even make sense. We need to find out what dx is. So how are we going to do that? Okay, well, we know a u, don't we? Okay, so let me ask you a question. What is du dx? Du dx is... du dx equals just 1, yeah? Okay, great. What's du?
X plus 2.
Du is x plus 2. No, that's not right. U is x plus 2. That's not du. How do I find out what du is? Okay, implicit differentiation of the u, take the derivative of both sides. On the left side is du dx, and on the right side, take the derivative of that, you get 1. Oh, we already did that. So how can I find out what du is? We can multiply a dx on both sides of our answer to our derivative here. Yeah, I know, right? This is weird. Multiply both sides by dx, and what are we left with? Du equals dx for this particular problem.
Okay.
Now, which means that, hey, what is dx? So if that's du, what is dx?
What do you?
Du.
What the?
But now we can plug this into there. And we're left with the integral of u squared. What does dx equal? Du. Okay, that I can take the integral of. What's the integral of u squared du? That's going to be
Divide by 3.
q cubed over 3 times plus c. Yeah. I mean, just forget that this is all a composite anything. We just took a integral like normal. Hey, what does u equal? We plug that back in,
Oh.
and we're left with x plus 2 cubed over 3 plus c. Okay, let's take a moment and just like think about the weirdness that just happened. Okay, so we took the derivative of this and then treated the derivative like a fraction twice and substituted in the dx? Man, we never even really thought about the dx, but I guess it's like an actual mathematical thing. Who knew? That's there for a reason.
Why?
Well, let us do this problem. So, let's take a moment and let's look at what we did. And we'll write down our steps. Now, first, we found our inside function. And named it I'm going to put this in a different color so it pops. And we named it U. Okay. Then we found du dx, we found du, and we found dx. Then we plugged u and dx into our function. So we go step 3, into our function, and then we integrated. Now this is a strange process. It involves us taking things that were just window dressing before and actually using those mathematical objects. Imagine that. So, so it's a strange process, but it really can take problems that are prohibitively difficult and make them much easier. Now this is not one of those problems. This problem wasn't too hard at all, really. But it would not be too difficult to imagine a problem where suddenly this is really difficult. And now we would have to use this method. Now this method has a name. We call it U substitution. Substitution. Or integration by substitution. Now, before we move on, we'll do one last thing to our formula over here. Now this formula is fine, but thinking about it in terms of f prime on the left and f on the right, that's kind of not a fantastic way of thinking about it. I mean, it's fine, but it's a little bit awkward. So if I just define f prime as f, okay, let me ask you a question. F of u. Is f of u the antiderivative of f prime of u? Is that correct? So if I take the derivative of f, what will I get? What's the derivative of f? F prime. So is f the antiderivative of f prime? Yes, it is. So we can rewrite this formula, so instead of putting an f prime in here, we'll just put an f in here and an antiderivative of f out here. This is the way that the book does it, though both formulas are correct. Oh, no, cap. Oh, what does capital F stand for again? Antiderivative, yeah. So these are both just two ways of writing down the same formula. Let's see. Okay. So let's go ahead and try a few more examples. How much time is on this video? 45 minutes. Okay. I can only record a video in chunks of an hour at a time, so an hour is what it'll take our 5 minutes. So that way, or Kiwa Community College won't observe the chaos of break time. Okay, so let's try another example. I'm kidding, of course. There's hardly any chaos, barely any chaos, almost no chaos. Okay, let's try another example. And this time, we're going to follow the U substitution method. Yeah, we're going to start easy, then we're going to work our way harder. Okay, I need 2 numbers. Give me a small number and a big number.
5, 10, 5.
Okay, I heard a 1 first and I heard a 10 just now. So let's say that we have to take the integral of x minus 1 to the 10th power dx. So how would you take this integral without U substitution? What would you do? Is it possible? Is it a pain in the butt?
Yeah.
Yeah, it would be x minus 1 times itself 10 times. You could expand that, but it would take like an hour just to expand it into a polynomial. Worth it. It's not worth it, guys. Okay, so instead we can follow our steps. So what is our inside function here? X minus 1. Okay, and what are we going to name it? We're going to name it U. So U equals x minus 1. Okay, so we found U. Awesome. Now what do we do? We need to find du dx. We need to find du. And we need to find dx. So what is du dx? 1. That was easy. So what is du? And what is dx? Now, we just plug in everything we can plug in. I see u equals x plus 1, so instead of x minus 1 to the 10, let's just rewrite this as the integral of u to the 10th power. Wasn't that much easier? And what can we replace dx with here? Du. That's not too bad. Du. Okay, and what is the integral of this going to be? What do we do with that? Thinking through this. Add 1 to get, so we're going to get u to the, awesome. Now, what is u equal again?
X minus 1.
Oh, and what are we missing from our? Plus c. Okay, so plus c. Now we can replace our u back with x minus 1, and we have our final answer of x minus 1 to the 11th power over 11 plus c. Yeah, you kind of feel, okay, yeah. So this it seems kind of basic so far. Why do we need to think about u's, du's, dx's? Okay, du dx. Well, what does this really say? The derivative with respect to, hey look, we have a function called u. We're taking the derivative of u with respect to x. What's the derivative of this function? 1. Okay? Okay, so this one, not too bad. It was just like our other one, du ended up equaling dx. Everything is nice and lovely. Now let's try one that's going to be just a little bit uglier. Okay, are you guys ready for me to erase this?
Yeah.
Okay. You good?
Yeah.
Okay. Okay, I need 2 more numbers.
8 more.
And 8 and 5. Okay. Let's say we have. Let's say we have to take the integral. Well, actually, say integral of e to the 8x plus 5 dx. Okay, so Suddenly we're not just playing with polynomials anymore. Ugh. Well, let's see. What is u? What is our inside function? Our inside function is, everyone? I wasn't everyone. Everybody, what's the inside function here? Okay. So, u equals 8x plus 5. That's our first step. We found the inside function and named it u. Okay, so what's our next step? We need to find du. We need to find du dx. What is du dx? Du dx is going to be 8. Okay, so what is du? Just dx?
Oh, yeah.
So what do we do to this to get du? We multiply both sides by dx. Du is not always going to be just equal to dx. So these cancel, and we're left with du equals 8 times dx. And what is dx? What do we do to get dx on its own? So we get, we're going to have to divide by 8 on both sides, right? So we get du over 8. Okay, fair enough? Okay, so, well, now we'll plug in everything we can. So, what can I replace 8x plus 5 with? With what?
U.
U.
Oh.
I can replace it with u.
8.
So u are unreplaceable.
Oh, shoot.
Okay, and what can we replace dx with?
No.
We can replace it with du over 8. Now, this is kind of weird, but this is just du over 8, yeah? Okay, what can I do with that? How about that? That's really a 1/8, right? Or what's being multiplied by 1/8? That's e to the u times 1/8 du. Hey, look, a constant multiple. What can I do with it? We can take it out.
We can kill it.
And we're left with 1 over 8 times the integral of e to the u du. Okay, y'all. What's the integral of e to the u?
ETU.
So, if we have to multiply our answer by 1 over 8, so our final answer is going to be 1 over 8. Well, not our final answer, but we have e to the u plus c. What's u again? And u is 8x plus 5. It'll add c to the whole thing. So there you go. What do you think? It's interesting, isn't it? Give me a second to check time. Okay, 5 minutes left. Okay. So what do you think of this method? Getting there? It's all right? Okay, so what problems are you watching this? We'll do a really complicated one. Let's see, about 5 minutes on that, but you know what? I think we'll do a really complicated one after the break. Let's go ahead and take a 5 minute. Oh, yes. Define du? Here? Okay, well, what is the derivative of 8x plus 5?
I know, but I'm saying like if it were to use it.
Yes, sometimes you're going to have more complicated stuff in there. You might have to use chain rules, you might have to use product rules.
Instead of just exponent.
Yeah, though we're starting nice and simply. And sometimes this formula does not always work. We're going to look at later today if we have time, but we're definitely going to be looking at the situations when you can use u substitution. It doesn't always work, but when it does work, it's the easiest way of doing it. integration is one of those things where everything we do where a lot of what we do is hard, so we have to look for easy paths and shortcuts in order to be able to do this at all. Okay, so let's go ahead and take a, yes,
What happens if you on the next step?
on where?
Does you plus
Oh, the du disappears when we take the integral. Like, what's the integral of 2 dx?
We're taking the antiderivative of that one.
Like, what's the integral of this? That's 2x plus c. The dx just disappears as part of taking the integral.
why do we have to find the t?
Because sometimes, because we have to replace dx with something, with a du. Because we can't just take the integral of e to the u dx. Because in order to take the integral, these variables have to match. Make sense? Definitely. Probably.
No.
What's that? That's what's the homework?
I'm in a break.
Okay, now we're taking our break. Okay. See you guys in 5 minutes. Boop. Okay. 5-minute timer. Rolling again. Awesome. Okay. So. What, Michael? Sorry, we're getting started again. We can ask after class. Okay, so we had. Okay. Now let's go ahead and try one that's a little bit more complicated still. Indeed, one that is AP examish. Examish? Let's take the integral of cosine of x squared plus 1 times x dx. I want to get you guys actually doing some problems from the book before we leave, so. Okay. Oh, whoops. My bad. I thought I was having you do work from the book. I guess I was actually having you do work from our worksheet. Okay. So, we have the integral of cosine of x squared plus 1 times x. So what is our inside function here?
X squared plus 1.
Our inside function u is x squared plus 1. Okay, what do we need to find now?
du dx.
We need to find du dx. And what is du dx?
2x.
2x. Just 2x?
Yeah.
Yeah, just 2x. Okay, then what?
We find du.
Then we find du. So, what is du?
2x.
It is 2x dx. And what is dx?
du over 2x.
Dx, so we divide both sides by 2x. And we get du over 2x. Okay, we get rid of this stuff here. Okay, so now what? What do we do now? We plug in everything we can. So, what can I plug inside of here? So it's cosine of what? U times x. So we haven't plugged anything into that x. Now, what's dx? du over 2x. Now this is the real magic of u substitution. Hey, can we take this integral right now? Yeah, because that x is messing everything up. But you know that dx is du over 2x. What cancels? The x's.
Okay, I'm lost. So you had got to put x with this one, du over dx.
So, what's up, John? Are you lost? We can go through this process. Let's go through this process again real quick. X squared, so u is x squared plus 1. We find its derivative, du dx, which gives us 2x. Solve for du, which gives us that. Then we solve for dx, which gives us that.
Wait, why'd you come up with X?
Because we have an x up top and an x on bottom. They cancel out. Leaving us with the integral of just, well, what can I do with this over 2 over here? That's really a 1/2, but what can I do with it? We can pull it all the way out. So this is really 1/2 cosine of u du. Okay, y'all. What's the integral cosine? Negative sign?
Oh, sign.
Just regular old boring sign. So, but we have this 1/2 out here, let's multiply everything. So we have 1/2 sine of what now? Of u. Let's see, but we know u, don't we? I certainly know u. What is u? The correct answer is u is us. U is x squared plus 1. That's from here. Plus.
We don't need to find the derivative of u anymore, right? You don't have to add that on to the side anymore.
You mean the du thing here?
2x part. Like if you were to take out the x squared plus 1, you don't have to find the 2x now.
No, you don't.
Okay.
We plugged in everything we needed to.
Okay.
So, what do you think of this process? We are recording, right? Yes.
Do you have a clear shot of the inside of your nose?
The inside of my nose?
Yeah.
God, I hope not. Okay. Nothing inside my nose but sorrow and darkness. Okay. So, there we go. What do you guys think?
It's alright.
Because the antiderivative of cosine is sine? That's my job. Okay. So now I think I need to give you guys some problems of your own. 360 math?
Yeah.
Okay, let's do it. Grab your books. Okay, grab your books, open them up to page 321. I'd recommend grabbing a partner. What do you got? This one. Oh. So, there's a couple of ways we can do this. Okay. You're really close. We can move the x to the 1. So is this x being taken to the 1? Or is sorry, this but not the 4, right? So the 4 can either stay down or you can turn it into a 1. Now you multiply. At this point it's a 1/4, which means that you just move
Sorry, I'll touch it.
this 4 is not being taken to the 1/2 powers, which means that this is not being affected by what's going on here. So you can move this up separately and pull this 4 out. as a 1. Now? Yes, of course you may. You can erase anything you need to,
Can I do a
if you want. Okay, you want to work? Where's your books? Got 'em? Okay, there's still plenty of empty whiteboard space. I want to see more people standing up. Okay, now, on page 321, I want you guys to start working on exercise 1. When you finish the problem, call me over and I'll check it with you. Yeah, of course. There's some method. That'll do too. So 321, exercise 1. Anything you can do. We add the exponents, yeah. So 1/2.
Okay, so we're not doing next.
2 plus a half. 2 plus a negative, which is positive or negative?
Oh, no. I forgot to.
Where you want?
There you go. Yeah, just multiply by 1/4.
First I need.
Yeah, that's like that. Well, you haven't taken that. All you do is get here.
Oh.
Distribute. So,
Oh.
don't. 321. Exercise 1.
Oh, wait, why did I ever see it?
So, exercise 1, starting with.
So then we find a theory.
I want that.
You'll survive. Okay, what's up? So this. Okay. No, you don't. Just think of it. Now you just take the integrals. What is the integral side of u? Oh, and what about that over 3?
Just say it like this, right? And then you find the antiderivative like that.
I don't quite follow what you mean. Well, this is correct so far.
Oh.
This is good so far.
Oh, no.
But you have to move this 3, right? You move to the front.
Oh, yeah.
You took the integral. You don't need that anymore. This should go in there. Yo, you took the integral. V is gone.
Oh. And then we plug in u.
You got it. So what is u equal?
Oh, read your marker.
You forgot one little thing. No, those don't cancel. This is on the inside. Because it's on this side of this. Oh, you forgot one little thing? It's round, crescent shaped. Plus two.
Oh, well, I'm just.
You're done. That's as far as you can take it.
Root catch.
Okay. Okay, so now we just take the integral. What's the integral of sine?
Yeah.
The 1/3. Mm-hmm.
It's negative. Oh yeah, antiderivative.
Awesome. Okay, go ahead and run over to page 321. Then practice use of. That's good. What?
And then you divide the whole thing by 2.
Yes. Let's say check your work, go on to 2. Look at which one. Because the antiderivative sign is. Okay, so this is where we got a little bit confused. The du just disappears when we take the u. It's basically just telling us where we stop. But what if this over 3? Is that right? It's a 1/3, yeah. The 1/3 became a 3. So just leave it there. But it's multiple. Yeah. You were tempted to order 2. Yeah, go ahead and go on to the next one. Okay. Okay, Jonah, what you got? Oh, you're just going to do it right now? Good. You're close. 1/3, not 3. There you go. Okay. You need to be able to do this on your own too, Jamar. Okay, Taylor, what you got?
Your girlfriend's not gonna be seen
It's perfect. For which number? We're gonna start with this one. But yeah, start with this one.
About 5 minutes left in class. I'm just going to have him keep working instead of doing an exit ticket. This will count.
Huh? I don't want you hearing my plans. Okay,
And then you solve for DU and DX. And these two
3x squared. Are you sure you're trying to skip steps? Do stuff in your head. It's not working out for you. Just follow the steps. Find u. Find its derivative. Find du. Find dx. And just plug stuff in. And it'll just solve itself. What you got?
And then find the.
Okay. Okay, so.
Oh, I should, yeah.
Wait, is that number 1 or number 2, Jonah?
2.
Oh, never mind. Let's go. But I'll be over there in a moment. Okay. So.
Can't. Cosine goes to negative sign right now. Negative sign. Cosine? It's just sine.
Does cosine go to sine?
Are you deriving or into? So the derivative goes sine, cosine, negative sine, negative cosine.
Sine, cosine, so it'd be sine.
So if you're going backwards, you go from cosine back to sine.
Oh, it's sine, yeah.
Does anything cancel there, Cameron? Do you have to cancel that?
So this one?
And, yep. Now that, and what if this is 4? What can we do with that? You can pull it out.
It's my seat.
I was like,
Okay, now we can just take the integral. Now don't worry too much about the du. It'll just disappear when we take the integral. So what's the integral of cosine?
Hey, son.
Mm-hmm.
You did.
Now you can plug that. Yeah, now you can plug that in. You're forgetting. Yeah, you already took the integral. You're just plugging stuff in now. You missing one more thing? Over 4.
Yeah, because I did my eyes. Is
What
that right?
you got?
whenever we're supposed to go to.
One little thing, the antiderivative of sine is negative cosine. You see a negative, just toss a negative sign on there and you're good.
Oh.
Okay,
Oh,
Hannah.
yeah.
Okay, so we got to here, and you're doing good so far. Does anything cancel out? They're gone. Now, what are we doing with this 4? Up and out. Okay, here's one little thing. Starts with a C, right? Starts with a plus, right? Plus C. Where's the plus C? There you go. That's it. I know, right? Yeah. These are like way easier than they have any right to be.
Wait, the root can we multiply it to inside?
No, it just
This is one of those situations where the inside is in more than one spot.
Yeah, but they two
Yes, no, these are like,
the same.
yeah, those are,
Same shape.
yeah, those are just, this is the inside of the secant function. This is the inside of the
So they're
tangent
just
function.
different places.
Yeah.
And you just do like.
Yeah.
Oh.
Probably, you can take one from anywhere. This one is not any better, but, plenty of markers in that box.
This one we want to bring forward and that the
dx. Okay, now from one page up. Antiderivative, the integral of secant tangent is so let's do the secant of u. The u, of course, is 2x.
No.
What do you think of this process? You missed one little thing. We're just pulling the 4 out. This is a over 4. Means this is a 4 in the front. It's 1/4. Same thing. Looks good, Jamar. I'll be with you in a moment. Okay, now this one is a little bit different. Okay, for number 3, take a look on the table on page 307. It is exactly that. That is correct. Okay, so for this one, you're going to need the table on page 307. Trigonometry points. Okay, the bell is going to ring in less than a minute. That's exactly right. Good job. Separate one little thing. Plus C. Plus C.
So I'm supposed to have the x there?
Oh, there is an x there. That should not have. It just, so the x, there was an x down. Oh. I see. There's an x here and an x down there. Those cancel. Yeah. Right? Oh, no, never mind. I'm crazy. Bell doesn't ring for another 10 minutes. I'm so silly.
Alright, cool.
It's like, they're fine. Okay. We'll keep working for about 5 minutes, so I can give you all an exit ticket. Okay. Don't feel reason. Just this one little thing. What is dx? U over 2. Is. I thought class seemed really short. If it was short, we would have more time. How are you guys doing? Folks on the task at hand? I don't care what oozes. You did. Now do number 2.
And number 3 and number 4 and number
Okay,
5.
The root. Okay. Next one.
What is U?
See Molly right there.
Oh, that's dUdx. Start by finding just the inside. So what is the inside?
He's like holding Wally's hand. He's like, look.
It's 2x squared, so write that down. Write down u equals 2x squared.
So just keep thinking like.
Okay, now what is d
Like, you
dx?
see this,
What is the derivative?
Yeah.
Anyway, just like this.
Yeah.
Yeah.
I'm just like, that's all, man.
And that's du dx. Okay, now what is du, and that's du
I like
dx.
how when you said you were thinking of it, and for
Okay,
some
so what's
reason I was
du
thinking
equal?
about the thing.
Oh.
28
How can I get du on its own?
I gotta go nuts.
Whole other paper right there.
Oh,
I can eat them. What you got?
what's the derivative of this?
Okay.
Oh, hey, you were gonna.
I was called for like 5 minutes ago by Tira, I'm sorry. I'll be right with you guys. What you got?
Like, is it inside, that inside has the other inside? So we like, this is that inside, this is the outside, another inside, straight, right? The room,
Okay.
the room.
Where are you going, Mike?
Go to Robert.
Never mind.
What's up?
My great chicks.
Oh, go fast.
The room. Or you look at it, so it's whatever.
So, or cancel or on. Perfect. Okay, who's calling now?
We keep the cube.
You have to take the integral, right? What do you do when you take the integral? What do you, or what do we do with that?
Might be secant u10.
I don't know. No,
Just-
Did you see the?
What's the integral of, say, x to the third power?
Yeah, how you know
I get it.
So, this
This
is
is where it stopped.
times 28 times u to the
Secant
fourth
squared.
over 4, right?
Yeah.
You pulled out that 7, so it's not there anymore. Fair enough? Now, you can simplify a bunch of this stuff here. 7 times 4 is what? 28 over 28 is. So we end up with u to the 4th power. Take it from there. What is u equal again? Yo! Looks good. Okay. U to the what now?
When you're solving for the integral,
Okay.
you solve it. So that's how this
So,
is the integral.
there's your problem right
Yeah, and then you do.
What's the derivative
You
of this?
basically.
It's not 7x. What's the derivative of 7x?
So then this is like all over it. And this is
This x is here.
So
Suddenly, it's getting easier.
yeah, 28, and these cancel out. And then it'd be u.
Not 7 over 1. It's on the bottom, right? So it's going to be 1 over 7.
Okay, you get it? I know, that's
So that-
Okay. Okay, well, let's go ahead and write it out. So it's going to be u to the 3rd power, right? What's that? Not to put that in. So leave it as a u.
Wait. Yeah.
There. Now, pull the 7 out real quick. Your wires are crossed.
Or is it?
Okay, keep going. Get your wires crossed. We're taking the antiderivative. So what are we going to do with this? Again, then we'll divide by the number, which is 4. So we'll be adding to the 4 over. Okay, and we've just done the integral, so let's see. But is this simplified all? How so?
Oh.
20 divided by the answer.
Remember dx is always multiplied by it, so it would be
20 divided by 4.
so it needs to be
What did these two divide out? What, 7 over 7? So all this stuff just. So we're left with 4. And what's u again?
How do you turn this?
We wait on plugging that in until the very last. Okay, I'm summoned. Awesome.
Oh yeah, so where the heck did you go into all of this?
Okay, so this one's a little bit tricky. So I saw that.
I just remembered that. Where does
Okay,
it-
so
how do you
here
plug
we
it
have
in after?
these two. You're saying u is 2x, right? Which means that's u. That's also u. How come that 2x is still there? Did you replace it? Yeah.
It is?
Well, that's what it says.
See, we have put two 2x's, so I guess we'll have two u's.
Michael, you get it.
Yeah. Okay. Now then, on page 307, we have a handy dandy table of
It is?
Yeah.
Inside the this.
hey, what's the integral of secant tangent?
So you.
Plus c. So this time we're not using x's, we're using u's. So it'll be secant of u plus c, right? So what's u again? Go ahead. Who's summoning me? Bogus. Okay. So,
If you divide by 1/3, what does that multiply by 3?
okay, so 6x. So this is really 20. How do we? What 4, 3? You can take the integral and use the derivative. What do we do with that?
Wait, so do we have to divide it?
That's take the derivative. We have to add 1 and then divide by
Also.
Okay, bell's gonna ring in about 1 minute. We don't have time, we can do it tomorrow. Okay, so-
Wait, let's go to
I won't be here.
Literally out of time. So, what do you guys think of this U substitution thing?
When it comes to 5,
Here it comes to 5, you're confused. That's a good thing that we will look at it tomorrow.
oh, it won't be here.
Oh,
Hey, okay, fine. Let me take a look. What do you have? Oh, so Sunday now it's not important.
What?
Kamisha Dennis Toasty. Kamisha Dennis Toasty.
Oh, 5. So hilarious. Okay.
It is not.
I did not. The grid checks yet. Okay. That was a good. Michael. Michael. Okay.
Yeah.
You have that. The office. Upper bad math science. Toasty Gani.
Okay, I gotta stop the recording.
We're still working on it.
So that was fun.
Just give us